Yeah. Next topic, or I can say, while microservice designing, you know that what are the bottleneck or what are the problem in a microservice monolithic architecture, and you are sure, damn sure, to getting those disadvantage. You are saying, okay, I need to build a microservice, but how you are separating small services independently? So just you need to ask a 3 question, and if the answer you are getting, then you need to split that service. First question is it have single responsibility, like earlier we said login is the one thing. So is it a single responsibility? If yes, then this will become a service. Build around the business capabilities. Is there we can expose the APIs over it? Yes, that also. And design for the failures. All the cases need to handle while designing the microservices. Okay. Why? Because it's are the linked system, 4 or 5, all are linked system. So if anyone, like here also, if anyone goes down, then it should. So if this system goes down, so we need to think all the failure scenarios so that our whole application won't bother or won't impacted much if one service goes down. That's why we need to think on all the failure cases. Okay, like earlier, this is the login service we can consider. So every request came here. After that, after the login, it redirect to the Paytm, like payment. This is a shopping thing, and this is one transaction. Okay, transaction or wallet, we can say wallet, and this is the cache service. So if you check, each one have the different responsibility. This have login responsibility, this have Paytm, this have shopping, this have wallet responsibility. Every database is connected only with his service, not with the this microservice payment database is not connected in between the databases. Data goes through, means if this microservice wants this data, that means this microservice pull the data from database and that head over to in form of a API. So this is the good microservice architecture you should define in such a ways. Okay, that's it about the basic microservice designing. We'll talk about the AWS. Suppose if you want to define, okay, we have the advantages, disadvantages, and the AWS microservices. So what are the advantages if you go with the microservice architecture? Small modules, yeah, correct. Easier to process adoption, yes. Anyone can onboard and start coding because there are very small and single responsibility, no complexity involved. Independently scaling, yes. If the multiple people are only accessing our shopping service, then we will add the currently 5 node, we'll scale to the 10 nodes, like here. If the shopping is there, we just scale this multiple times. Okay, if database load is increased, then we'll create a master slave here. Okay, like this. So this is very easy to scale is there. Dependency we removed, unaffected from other model. If there is a problem in the shopping, only shopping service goes down. The payment and wallet is still remains same, means they are using. This is a deploy, update, replace, and scale at any time. It means address rule is this. Security is increased because at every layer you are adding some security. So that's the way security get increased at every point of multiple security. Means if this payment is exposed to the third party, that's why here also we are adding additional security. So multiple layer of security get added. And open standard means I can build this payment in a Java, this is wallet in a Node, and shopping in a Scala. So that also possible because here the language is not barrier for us. Each one are an independent thing. Okay, disadvantages, there are a lot of complexity because each service connected with each other and talking and sharing the data. Skill developer are required because microservice is need to know from end-to-end point of thing because it involves a lot of complexity in a handshake and all the things. Apart from system designing also get crucial in a microservice in architecture because the network, here we mentioned that network users and network latency also need to take care because currently we are directing connectivity with the database if you want, but here we are exposing the data through the API, so that network latency get involved. Independent deployment are getting complicated because some shopping services get down. We should need to think all the failure cases we discuss when how to design a microservice. That time we discuss point that all the failure cases need to handle. If any misses, that also impacted our business. Secure, we say it's a more secure and less secure, both the things, because if you add each layer security at each service layer, that become a more secure. But if just one second, earlier login at this place only security is there, then you have less security. But if you do the service security validation, authorization, and authentication at all the 4 places, that will become more security of your system. Debugging get difficult, but currently in the systems there are multiple tools like Kibana, Greylog, and multiple tools are there, so you can easily get the log. But yeah, that's required the expertise to ELK kind of stack to for your microservice. Yeah, that's the basic about the microservice architecture. If you want more details about, if you want to design Paytm, make my trip, IRCTC website, so all the thing you can let me know. We'll create one session for that and we discuss over it. But high level, this is it. But this is for your private thing. But if you want to build your microservice in Google Cloud Platform or AWS or Azure thing, I just mentioned AWS. Let me know if you want on GCP and AWS. Sorry, GCP and Azure. We'll discuss more about that. But yeah, so AWS microservice architecture means this is a suppose end user want to connect, then they will directly connect to the RLB, Amazon Load Balancer. He will redirect to the Amazon ECS or a Lambda function or EC2 instance, any EC2 thing or any containerization tool that have directly request redirect to all this stuff. And here we are processing our request, and whatever data we required, suppose ELK is required, we'll connect to the Amazon Elastic Cache. The database is required, we will connect Amazon Oro, and if DynamoDB is required, we'll connect with the DynamoDB and process it request, and through the response will redirect to the LB. If request is like the CDN, means the data which is static content, if you want, will connect with the Cloud Foundry, and Cloud Foundry is based on S3, so Cloud Foundry is a CDN. So all the data content delivery network, it request route through this route, and the business logic request route through it by this. Okay, this is the AWS very basic microservice architecture. Earlier I also said, if you want to build systems like Twitter, YouTube, Amazon, or anything, just let me know. We'll create a session and we'll build for you. Yeah, that's it. Thanks for all. Yeah, I'm good. Bye.